plane. This is also known as the Cartesian plane. Let's say we have point P and point Q on this same Cartesian plane. So you have y-axis, and then you have the x-axis here. Okay, so now there are certain concepts that there are certain things that we can do on here that are important when it comes to maths. So for example, we can calculate the distance between these points. That's the application of this. So there are many applications. The first one that we're looking at is for calculating the distance between points. So if I've got these points here, I can connect them by a straight line. Okay, something like that. Right? Now, to calculate this distance, I have to consider two things. So there are two straight lines here. There's one line which is going like that. There's another line which is going like this. These form a right angle. And so if this was A, and this was B, and this was C, remember the Pythagoras theorem, okay? This is what we go back to. Theorem, okay? This is what we go back to. So what does it state? It states that the square of this and that equal to the square of this one here. So meaning that C squared is equal to A squared plus B squared, right? And so if we look closely at this, this is just from this point to that point here. So this is the x, but the x here we say is x2, and the x there is x what? x1. So we can say that distance from here to there is x1 minus x2, like that. Then from here we can come back here and look at this, and then look at this as well here. So there, and then we look at this one here, it will give us this point here. But again, if we just check in terms of the y's, this will be y1, and that will be y2. So we can say this is B, and then A will be y1 minus y2. Okay, so now if we replace these into that equation, we'll find that C squared, which is the distance that we're looking for, which is D. So C squared will be, we said that it's A squared plus B squared. So it's the same as this and B squared. Okay, we square this plus y1 minus y2, the square of that. C, which is D, distance. So we can already say that this is D. Okay. Or we can say that this is P and Q. So we can say distance between P and Q is equal to. Now we can, remember we talked about balance, that whatever you do on one side, you do on the other. So now we find this. Okay. So that is the distance. So normally X will have a number, Y will have a number, Y1 will have a number, Y1 will have a number, X1 will have a real number. Then those are the ones that you replace in here to get the distance. So let's do one example. For example, if P, I'll just put it here. If P was 1, let's say if Q was 1, -2, like that, and this one is 8,9, what would be the distance? So the distance here will be, we can say distance PQ is equal to, now we're replacing our equation. So we start with the x's. So the x is 8 here. We can say 8 minus 1, 8. And then the x2 is 1. So we do it like that. okay, plus we get another one here, that's 9 minus 2, the square of that, so we get 7 plus, this is 9 plus 2, like that. So this will give us 49 plus 11 square. Still go for a square root there. This is 49 plus 121 square root. And then this will give us square root of 49 plus 121. That gives us 170, like that. Then we get the square root of this. That will be your distance. The concept that we can use is to find the midpoint between these points. So again, it's good to think right angles when we are dealing with these Cartesian planes. So now we have this, and we want to find the midpoint of these, which will be x, y, right? So now what we do with this is we extract this line. Okay, we extract it like that. And then we have our points there. So we then put our point here, okay, which is the midpoint, and it's x, y. This is x1, y1, which we call P, and then this is x2, y2, which we called Q. And this is a point, some other point, M, midpoint, okay. So what do? We make right angles here. There's a right angle here. And then we can also have another right angle there. So now let's find what x will be here. Okay, so we're looking at the midpoint. So this is 1, this is half, 1/2, or this is half, and then that's half. Meaning that PM is equal to QM. Okay, PM is equal to QM. So the distance from here to there is the same. So we get the distance concept we did in the last video, and then we in the last concept, and then we use it here. So now how do we equate these two? We can just equate on one plane. So we'll equate on the x. So we can say x minus y1. So, or we can say x1 minus x, which will be this distance, should be equal to this distance here. Should be equal to this distance here, because we're looking at it in one plane. So this one will be x minus x2. So those two are equal. Now what do? We I'm thinking I bring this side, because that's where my x will be positive. So I take x2, I take it the other side. So I have x1 plus, this one changes to positive. We looked at various ways of doing this. Then this also goes there, becomes positive. Then that is x, like that, right? So now I'll flip this. This becomes 2x, because we are adding variables here. We check they are the same. The exponent or the powers are the same. So those can be added. So 2x equal to x1 plus x2. So now we divide here and we divide there. So x in that single plane becomes x1 plus x2 over 2. And y will also can be dealt with in the same way. And then it gives you y1 plus y2 over 2. Meaning that the midpoint itself now will be x, y is equal to x1 plus x2 over 2. Then the y value, the y1 plus y2 over 2, like that. So that's what we get here. Now we know what this is. So this is our example. Always we just bring out the formula. So we say m x y is equal to it's going to be x1 plus x2. Then this one will be y1 plus y2, like that, over 2. Now, here we collect our terms. This is 1 and 4. So 1 plus 4 over 2. Then this one will be 2 plus 4 over 2. So then we have 5 over 2. And then we have 3 this side. That will be our coordinates.